everyone. Now the question we are going to be solving here is a past question from SSC private. This is alternative to volumetric analysis. Alternative to volumetric analysis, that is alternative to practical chemistry, volumetric analysis. Here we are given, if you go to the description section of this video, you will see the full details of the question. But here I want to be solving this in order to save a little time. So here we have the table of what we are given. Unlike just like every other alternative to practical, they will give you incomplete table and ask you to complete it. Here we have a table here. Now what we do here, they are trying to check, assess your ability of knowing how to do to find the volume of E used and how to do the calculation involved. So here, if you look at this very well, you have 19.70, we have 19.55 here. So to get the value of this, you need to subtract what you have here from here. So since we have this, we have 19.55 and 19.70, if you add it together, it will give us what should be here. If we add it together, what we have is 39.25. So in this case, altogether, since if we subtract what we have here from here, we'll get 19.30. That means to get the value of this, we subtract 19.30 from 29.80. If we do that, what we have will be 10.50. So here, 0, subtracting 0 from there, we have 19.40. So here, the next thing said that we should calculate from the question there, said that we calculate the average volume of E used. The average volume of E used. To calculate it, now we're going to be using the one that are very close to each other. We have 19.30 and 19.40. So the average volume will then be volume of E will be equal to 19.30 plus 19.40 all over 2. So when we do that, we are going to be getting 19.30 plus 19.40 divided by 2. We have what we have here will be 19.35 cm cube. So that's what we have here. So the next question they said that we should calculate the volume of calculate the concentration in mole per dm cube of D. D is the sodium trioxocarbonate. Now, for us to actually do that now, what we're going to do is we use our relation. This is E, V, E, and then C, D, V, D equal to E over D. Now, this is the mole ratio which we'll get from here. This for E is what? 2, equal to 2. For D is equal to what? 1. For the volume concentration of this, in the question said is 0.09.905, and then the volume of this other one is what we have here, 19.35 cm cube, and the volume of this from the question we say that 20 cm cube. So the one we are looking for now is the concentration. So now we're going to add up those things together. If we join them, we have a 0.095 times 19.35 all over D times 20 equal to 2 over 1. To multiply this, we have 40 CD equal to 19 points. Equal to 0.0905 times 19.35. So if we go ahead so what we have here will be CD will be equal to 0.0905 times 19.35 all over 40. That will give us multiply by 0.0905, no, 05 divided by 40. So what we have is 0.0438 mole per dm cube. So that is what we have. Now the next question is about solubility. The next question said the solubility of sodium trioxocarbonate in the mole per dm cube at 250 degrees Celsius. So to solve this one, what we're going to do here is to use the dilution formula. Since we know that we use a certain volume of that is 35 cm cube of a saturated solution, to make up to 1000 dm cube of that solution. So to get the concentration, we need dilution formula. This dilution formula is this. Concentration of that 35 cm cube, we don't know, but we know the is a 35 cm cube in volume. Concentration of this in dm cube of the solution is 0.0438, and the volume of the solution is 1000 cm cube. So now to get the volume of the concentration of the saturated solution will be 0.0438 times 1000 all over 35. So that will give us, if we do that division, what we get will be times 1000 all over 35. We have 1.25 mole. That's the concentration of that. We have 1.25 mole. Okay, we are done with that. The next question we have there is, let's look at the next question. The question number 3 question there says that the volume of the saturated solution that should be evaporated to yield 25 grams of sodium trioxocarbonate. That's the next thing we are going to be solving now. Now we know that 1.25 mole of the saturated solution contain 1000 cm cube. Is what is contained in 1000 cm cube. Now, for us to do this, for us to go by moles, we need to convert 25 grams also to moles. 25 grams converting to moles will be divided by 106, which is a molar mass or relative molecular mass of the compound in question. You do 25 divided by 106 will give us equal to 0.236 mole. So then it means that 0.236 mole will be equal to, will be same as 1000 over 1.25 times 0.236 over 1. So now what we do again, let's see what we get here. Divide by 1.25. So the volume will be then be 188.7 cm cube, or we can make it approximately 189 cm cube. So that's it. But then we can also solve it in other way around. The other way around of solving it is converting this to grams. If we convert that to grams, what we have here is, that mass, mole, is equal to mass over molecular mass. So what we do here is mass now will be mole concentration 1.25 times 1.25 106. So that will give us 1.25 times 106. We have 132.5 grams. 123.5 grams. So now we're going to solve it another way and with another method. To solve it another method, remember what we have here. We have 1/8 approximately a cm cube. So we want to compare them to see if then you can choose the one that is okay for you. What we have here will then be 132.5 is contained in 1000 cm cube. Then 25 grams, this is gram, will be 1000 over 132.5 times 25. That will give us we have 1000 times 25 divided by 132.5. Then what we have again is equal to 188.7 cm cube. The same thing approximately to 189 cm cube. Now it depends on the one that is easier for you. You can convert it to mass, convert that to mass and solve the problem, or you use it in mole. That means if you're using mole, you need to convert this other one to what in mole, because you have to work mole volume or mass volume as the case may be. So let's go to the next question. We have the last question. That should be the last one. It said that mass of carbonate 4 released when 1 gm cube of the saturated solution reacted. Now from this other one, from this what we have there, we are going to calculate. We know from the chemical equation, we find out that 1 mole of that will give us 44 grams. Now let's just look at the chemical equation first, so that we'll be able to know what we are actually talking about. So here we have carbon, 1 mole will give us this. This is 44 in grams. This one is 1 mole. 1 mole of that. Oh, now overrushing. 1 mole of this will give us 44. That means what we mean. 1 mole of that will give us 44. Now, but what we have in the 1 gm cube of that saturated solution, 1 gm cube is what? 1.25 mole. So what we are going to get here, what we are going to be looking at is what is going to give us. Okay, now this will give us equal to 44 over 1 times 1.25. That will give us, when we multiply through, we'll have 44 times 1.25. That will give us the mass will be 55 grams. Thank you so much for coming this far, and we would like to encourage you to subscribe. If you have any question, you can leave it as a comment, and also you like and share. Thank you so much for this wonderful time.